So we need to determine if a function is linear or nonlinear, and they can give it to us in three different variations. The first way that we're going to take a look at is how do you tell if a function is linear if it's in an XY table? And on the very next screen, we'll take a look about what to do if it's nonlinear. So basically, the first part is when they give you a table representing a function, they say, is it a straight line or not? How do you go and do that? Well, the first things you have to do is you have to go and do a little bit of work basically of finding the slopes. So I'm going to take the first point and the second point and plug it into the equation of y minus y over x minus x. And I quickly find out that the slope for these 2 points would be 3 over 2. Now up until this point, you've assumed that you will get 3 over 2 no matter which 2 points that you use. And that's not always true because when they're saying, hey, is it linear or is it nonlinear? What you have to do is you have to then, where you use the first 2 points, you have to go use the second point and the next point after that one, the second and third. And so you do the same thing, y minus y over x minus x, and we'd find out it's 3 over 2. And if you have the same slope, then you just basically keep working your way down until you've completed the whole table. And if you notice, I need to take this third one and use it with the fourth one. And I find out again that my slope is 3 over 2. So if you have, this is the basic thing, if you have the same slope, then it's linear, okay? And I've got 3 over halves, 3 over 2, 3 over 2, or 3 over 2. And your calculator might show this one as 1.5, but hey, 3 divided by 2 is 1.5. It's the same slope all the way down. So this is how you can do it without graphing. If you wanted to see what it looked like as graphing, which I certainly do not recommend you doing, um, basically you graph these 4 points out and see if you can run a line all the way through the 4 points. And, you know, here's 6, 12, here's 2, 6, here's 0, 3, and here's negative 3, 1/2. They're all on the same line. So yes, this is definitely a linear function, but how can you do it without graphing? Take the first 2 points, get a slope. Then take the second and third point, see if it's the same slope. If it's the same slope, go to the next set of points, the third and fourth one. So that's pretty straightforward. What's it mean if suddenly we take almost the exact same slopes, I'm sorry, the exact same points, but I change 612 to 616? Well, you don't know whether it's linear or nonlinear at the beginning, so you basically have to go through and run this test of checking to see if the slope is the same. The slope here would be 3 over 2. And then I take 0.26 and 0.616, these 2 points, I run it through and I find out that my slope is different. It's 5 over 2. Well, that's no good. If the slopes are different, if m is different, then it's nonlinear. It means that you could not put all 4 of these points on a straight line. So let's take a look and see what it looks like if you graphed it. Here's negative 3, negative 1.5. Here's the 0, 3 right here. Here's 2, 6 right here. And the 616 where it was 612, now it's sitting at 616. Let's see if we can get a line to connect all 4. I can get the line to go through 3 of them, but I can't get this 4th dot. And so let me get to a green highlighter here. You've got this dot that's not on the line. You've got the other 3 that are on the line. And so that's the reason we would say, hey, this is nonlinear. And how do you do this without graphing? Literally, you just start getting your slopes. You take the first 2 points, get your slope. Then you take the second and third point and see if they're the same. If they're the same, then you just keep on going down. If your slopes are the same, it's linear. If your slopes are different, it's nonlinear. See this point? It's way off. And that's what the non-matching slopes is telling you. Now, that's the newer part. Here's the older part. How do we tell if a function rule is given to us, or the equation, if it is linear or nonlinear? Well, you take a look at your um, variables. If the variables have exponents, nonlinear. If the variables don't have exponents, it's linear. So let's take a look here. I'm looking at my variables, the y and the x. Neither one of these have an exponent, so it's linear. Here's my y, here's my x. This x right here has an exponent, so it's nonlinear. Here's my y, here's my x's. That's all my variables. Because this y has an exponent, I'm going to say it's nonlinear. Okay, so at this point, you can handle if we give you an XY table. We can also uh, have you handle it if we give you an equation or the function rule. What do they do if they give you the graph? Well, just look at it. See this straight line right here? Because that's straight, I know it's linear. See this right here? It's curved, it's not straight, it's nonlinear. That's all you have to do.